Welcome to Learning with Philemon. In this video, we will be looking at how to determine the empirical and molecular formulae of a compound. The empirical formula is defined as the simplest whole number ratio of atoms of each element present in a compound. A compound could have the empirical formula CH2. This means that for every one carbon atom, there are two hydrogen atoms present in the compound. Note that the empirical formula does not always represent a possible compound. As you have learned in the bonding topic, it is not possible to have CH2, as carbon forms 4 bonds, not 2. The molecular formula is the actual number of atoms of each element present in a compound. The compound with an empirical formula of CH2 could have a molecular formula of C2H4. Note that by multiplying the subscripts of the empirical formula by 2, we get the molecular formula. Dividing the subscripts of the molecular formula by 2, we get the empirical formula. C2H4 is an actual compound called ethene. So ethene has the molecular formula C2H4. This means that there are 2 carbon atoms and 4 hydrogen atoms in the compound. Ethene has an empirical formula of CH2, as for every 1 carbon, there are 2 hydrogen atoms. Now let's see how one determines these formulae from data. A typical question would look like this. A compound is composed of 52.18% carbon, 13.04% hydrogen, and 34.78% oxygen. What is the empirical formula? The composition of a compound is determined by an analytical technique called elemental analysis. In this technique, the sample is combusted and the percentage by mass of each element is determined. To answer this type of question, you can set up a table with the elements and the heading of each column. If we assume that we have 100 grams of the sample, we can convert the percentages into grams. We choose 100 grams so that the percentage values are the same as the gram values. The first step is to divide each mass by the respective atomic mass of each element. Remember that the number of moles is equal to mass divided by molar mass. This gives us the moles of each element. Note that it is advised to keep more significant figures or more decimal places in your answers so that your result is accurate. The second step is to divide by the smallest number. In the case of these 3 numbers, the smallest number is 2.17 mole. So we divide all the moles by 2.17. This gives us the molar ratio of the elements. For every 2 carbon atoms, there are 6 hydrogen atoms and 1 oxygen atom. This means that the empirical formula must be C2H6O. Note that this is not the molecular formula. Now let's see a question where the molar ratios are a bit more complicated. In this question, a compound is composed of 43.67% phosphorus and 56.33% oxygen. What is the empirical formula? Following the same steps, we get a ratio of 1 phosphorus to 2.5 oxygens. We cannot have a decimal number in our empirical formula. We cannot have P1O2.5. Instead, we multiply the numbers by a factor that converts both numbers into whole numbers. In this case, we multiply by 2, getting the ratio of 2 to 5. The empirical formula is therefore P2O5. But how do we determine the molecular formula? A follow-up question could be the following. If the molar mass of the compound is 284 grams per mole, what is the molecular formula? We have already determined that the empirical formula is P2O5. The first step is to calculate the molar mass of the empirical formula by adding the atomic masses of the elements present. The molar mass of P2O5 is 142 grams per mole. The second step is to divide the molar mass of the molecular formula given in the question by the molar mass of the empirical formula calculated. In this case, we divide 284 by 142. The final step is to multiply the subscripts of the empirical formula by the factor determined. In this case, we multiply the subscripts by 2. The molecular formula must be P4O10. If you calculate the molar mass of P4O10, it will be 284 grams per mole. Note that if the molar masses of the compound and the empirical formula are the same, then the molecular formula is the same as the empirical formula. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.